Welcome back, students. In this video we're going to cover lesson 4.4, that is composition of transformations. This is the last topic in module 4. Got our two standards below the title. Vocabulary, so composition of transformations. A transformation is applied to a figure, and then another transformation is applied to its image. A glide reflection is the composition of a translation followed by a reflection in a line parallel to the translation vector. So, like a glide reflection, first your figure is reflected over here, and then it's translated. So let's say if we had a little, we'll just make this guy here, and let's say he's reflected over here. And then say we moved him, we move him to the right and left first. So we say we went right 3 and down 2. So that's what it means. So glide reflection, it would end up from here to here. But that's the quick version. Theorem 4.1, composition of isometries. So composition of isometries, basically the same as the transformation. So it's one or more isometries, it's one or more movements, and we'll demonstrate that below. Theorem 4.2, so reflections in parallel lines. And so we're going to talk about this here, and then it's not going to be mentioned again till the flip side of the page. So let's just refer back to this. I'm going to remember, I'm not going to flip back, but you'll need to either remember what I'm saying or flip the page back. But so when we're reflecting a figure, so P is reflected twice over these parallel lines, K and L. The composition of two reflections in parallel lines can be described by a translation vector that is perpendicular to the two lines. So down here, because if it's perpendicular to these lines, and it's twice the distance between the two lines. So whatever this is from here to here, where your translation is going to be twice that distance. So whatever the number they give us here, it's 2 times that. And you'll see on the flip side of the page. And then over here, theorem 4.3, reflections in intersecting lines. So you see the lines intersect here. Composition of two reflections in intersecting lines can be described by a rotation that is about the point where the lines intersect. So that'd be point P here. I'm just going to write on it. And through an angle that is twice the measure of the acute or right angle formed by the lines. So this angle, so your distance here is twice that, is what it's saying. So again, we'll come back to that on the flip side of the page. So for now, let's go to example 1. So I'll do this one. We'll do the math, you do the coordinate rules for the points, and then we'll graph it. I'll do it in different colors so you can see where it goes, because it's gonna be like this one's a translation, so it's gonna move left to right, up and down. So it'll scoot over, and then it's gonna be reflected in the x-axis. So if it moves here, it'll reflect down here. If it starts here and moves over, it'll reflect here. We'll see. So translation and reflection in the x-axis. So we have 3 points. So let's just get into it here. So to translate along vector -4, 0, remember the number on the left is your A, the number on the right is your B. It's x plus A, y plus B. In this case, it'll be, so our first movement will be xy becomes x minus 4, and then y plus or minus 0 just leaves you with y. So that's how we write that. And then the second movement, so once we get this point, it'll become our x comma y. And then we're going to do the reflection in the x-axis, which when we reflect in the x-axis, the x stays the same, the y is the opposite because it's going to move from here to here. When we do it in the y-axis, the y stays the same, the x changes because you're going to move across the page. But you keep x and y in the same spot. We don't flip until we do other movements there. Excuse me. Okay, let's see. Trying to make this. Well, yeah, we're just going to do the points in different colors. So we're going to start with P. P is at 1, 1. So 1, 1. Let me just 1, 1. Okay. So your x, y. So this is 1. I'm not going to have room to write it all out, but your 1 minus 4. So 1 minus 4 is negative 3. Next you have 1, well, it's just y, so it's just 1. Okay, cool. All right, we're going to bring that down here as our x, y. And then it's, so for P prime, so x comes over, y is negative y. Okay. I'm just going to do our points in these other colors real quick. So P prime is, well, actually we need to graph both of these. So it'll be where we start, the first movement, so 4 over, and then the reflection. So let's do this. So negative 3, negative 1, 2, 3, positive 1. So see how this is 1, 2, 3, 4 over? Well, that's our 4 over, and it didn't move up and down. Okay, excuse me. Pencil dropped. Okay. Now Q. I'm not going to do the points till I'm done in a minute. It's too much back and forth. So Q is 2, 5. So 2 minus 4 is negative 2. And then our 5, I'm going to do a better 5, comes over. So this becomes our x, y. So negative 2, 5. So Q prime, our x stays the same, negative 2, but our y changes to negative, so negative 5. Excuse me. And, oops. Let's do this. All right, so R is 4, 2. So 4 minus 4 is 0. And then 2's over here. So we got 0, 2. And your R prime, so 0 can't change, which it doesn't. X is the same. Y is negative y. So there's your R prime. Technically your R prime, but as I've said in class, if we did the prime with every movement, that's a whole lot of primes that I'm saying. So we're just going to leave it at prime one time. So P started out negative 3, 1. Then it moved. No, it started out at 1, 1. Excuse me. Then it moved to negative 3, 1. And then it ends up at positive 3, negative. Wait a minute. Hold up. I wrote that wrong. I wrote it, but I graphed it. Yeah, I wrote it and graphed it incorrectly. Oh, jeez. Bro. So let's change our starting point. Well, we'll leave the 1, 1. Let's make the next, so negative 3, positive 1. Okay, this is just, yeah. And then negative 3, -1. So it's moving here. Okay. Q starts out at 2, 5. Let me just go ahead and do the 1, 2, and then 1, 2, 3, 4, 5. Whoops. I need to make that where you can see a little better. Hopefully you guys know the graph. But so 1, 2, and then up 1, 2, 3, 4, 5. So I missed the point there. Good grief. All right, and then P is 4, 2. So 1, 2, 3, 4, 1, 2. Hold on. Let me just line it up, then we can look at it. Okay. So we're gonna scoot that extra bleed over into our triangle. All right, so the first movement had P at -3, -1, -3, -1. Okay. And wait, actually, oh geez, 0, -2. I just totally screwed that up, didn't I? Or did I? No, I'm looking at this. It's, yeah, 4, 2. That's right. Okay. All right, so -3, +1, and then -2, +5, 1, 2. I need to do it in green. Oh, wait, it is green. Good Lord. Still looking at the purple. Okay. And then 0, 2. Okay. So my dots being over make this look a little bigger. They're the same size, but this is 4 over. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And you could have done this without this. Maybe should have done it that way. That's okay though. All right, so now our so -3. Oh yeah, -3, -1. Okay, and then -2. So whoops. So -1, -2. Wait a minute. Let's do this again. -2, -5. Excuse me. See, I don't. Let me see. Hang on just a second. Okay, so -2, -5, 3, 4, 5. So right here. All right, and then 0, and then -2. I don't know. There we go. All right, so we scooted over 4, and then we'll reflect it in the x-axis. It's kind of leaning a little this way, so it would lean a little the opposite way. Like I told you before, when you reflect, you're looking in the mirror. It's your left eye. The person in the mirror, it's their right eye. So if it leans a little to the left, this will lean a little to the right, so on and so forth. So number 1, example 1, check. So my suggestion, to make it easy, go ahead and graph your J, K, and L. J, K, and L. Determine the coordinates of the vertices of the image after a translation along. So you, again, scoot it 4 to the left. And if you want to just, wherever it's at, draw the 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 4. So if you draw those, you could do that over here, and then reflection in the y-axis. So it's going to be this way to this way, or left to right or right to left. So you can skip this step and just count because you're reflecting, or you've got your points. This part, the third part's easy. Either way. All right, I'm gonna scooch down, but yeah, you're gonna graph it after the translation and then reflection in the y-axis. So we're gonna scooch down here to number 2. I'll do example 2. You guys will do example 2 check. So this is gonna be, yours will be x-axis, rotation 270 clockwise. Ours is 180. Let's see, 180, and then a translation along vector -2, 4. So the 180 rotation, so x comma y, becomes -x comma -y. So remember, if they're negative, it's positive. If it's positive, it's negative. We're taking the opposite sign. It's easy to get hung up with these negative x's and stuff like that. This just means we're taking the opposite of this. If it's a negative, it becomes a positive. If it's a positive, it becomes a negative. Same with that. So that's your new x comma y. And then your next is a translation along -2, 4. So it's x minus 2, y plus 4. All right, so if you see that. The neighbor's very loud right now. All right, so let's start with point A. A is -6, comma, and see, it's really easy to jump the gun. -6, -2 becomes +6, +2. Oops. And now we're going to subtract. So 6 minus 2 is 4. Again, so 6 minus 2 is 4. And then 2 plus 4 is 6. Double check. Yep. So this is A prime. I'm going to kind of box it in because I kind of messed that up. All right, let's go to B. Let's see. -5, -5. So opposites, it's going to be +5, +5. What I may do is start skipping writing it there. I guess it doesn't matter. Okay, so now 5 minus 2 is B prime is 3. 5 plus 4 is 9. So we'll box this in. I think we can still do it from over here. C. -2, -1. So your excuse me. Your -x comma -y would be +2, +1. All right, then 2 minus 2 excuse me, is 0. 1 plus 4 is 5. Yeah, I'm just checking my stuff. All right, so let's graph these people. -2, -6. So -1, -2, -3, -4, -5, -6. Well, wait a minute. Yeah, -6 and then -2. All right. B, -5. So if this was 6, I'm going back 1 and then 1, 2, 3, 4, 5. And then C's at -2. this was C. A. Okay. Now, first movement is a rotation, and that's why I'm making sure we see the letters. I want you to see how it looks after a rotation. So this is positive 6. So 1, 2, 6, positive 2. And 5. So 1, 3, 4, 5. 1, 2, 3, 4, 5. And positive 2. Positive 1. Okay, so see how when we rotated, so A was on top, B was on bottom, now B's on top, A's on bottom, so it rotates. All right, so now, second movement, so we're going left 2 and up 4, so it should be left 2, up 1, 2, 3, 4. I'm going to mark these as we go, just so left 2, so from here 1, 2, that's the line, then up 1, 2, 3, 4. And then from here, 1, 2, and then up 1, 2, 3, 4. So we're going to do that, but we're going to come back with, we're going to turn it green. So let's now look. So 0, 5, so 1, 2, 3, 4, 5. And this again, I made it too big, but that's okay. Let's see. All right, and positive 3, so 1, 2, 3. Up 9, 1, 2, 3, 4, 6, 7, 8, 9. See? And nice when it all comes together. I know it is for me. And 4, 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Ta-da! See here. And this is B. This is A. So, see, you can do it with the graph, just count and go, but we did the math over here, so it kind of double checks you. All right, so to the right, this is you guys. So reflection in the x-axis, rotation 270. The 270 clockwise is the same as 90 counterclockwise, so that should be x comma y is negative y comma x. I think you guys need to look it up. I'm gonna flip over. This is where, let's see, hold on. Yeah, so back to the top of the first page, the original double the distance, double the angle. All right, so example 3, so refer to the figure. You're trying to describe the single transformation that maps a preimage to the image over line N and Q. All right, so from here to here, you have your, excuse me. Let's see, hold on, wrong page. So what did it say here? It said so it's a translation. In this case, it's going down. So down. Like over here, you're going left. Here, we're going down. So translation down. And then it's this. So 3/8 times 2. Whoops. Yes. Times 2. That ends up being 3/4 of an inch. So it is a translation down 3/4 of an inch for this over here. And this is all kind of goes together. Sorry, I forgot where So this will bring down here. Excuse me. All right, so for this guy, so remember this is considered a rotation, because see it's doing this number. It's terrible, but and here, so it's rotating. So this is a rotation, and you see it's going left to right, so this is counterclockwise. And so 45 times 2 is 90, right? So this is a 90-degree rotation. I could have wrote that better. Rotation counterclockwise. So again, over here, twice that number. Which direction are you going? This is a translation. It's all right. Let's look down here. Finish this video off. It's gone a little longer than I intended. My apologies. I try to explain for those of you that are watching and paying attention, and I appreciate it. All right. So let's see. Yeah. All right. Example 4. Are triangles ABC and DEF congruent? Now we could check the measurements and to verify. With the book giving us this to write in, obviously they are, and we're going to describe how we got from here to here in 2 moves. It's going to be described in this small proof. So ABC can be mapped onto DEF by A. So if you look, so A and B, see how it's A, B, C, D, E, F. So A and D go together, B and F go to E go together, and C and F. So see, it's first letter, second letter, third. So first with first, second with second, third with third. So A, D, B, E, C, F. So notice A and B are at the bottom. Here they're at the top. A is on this side. See if it slides around, not if it reflects. If it reflects, it's going to go BA. But if it rotates around, say if we went around the origin, notice how this is 2 away from the side. We would see B is at -1, -2, +1. So it would be +2, -1. No. -2, -2, +1. It's going to be +2, -1. So it would go here. And then A is -1, 2, 3, 4, +1. So let's go +1 and then 1. No. Lord. What am I looking at? Oh, yeah, it's over here. +1, 2, 3, 4, 1. And then C is 2 away, and it's on the same line as this. So, well, let's just say -1, -2. Then +1, 2, 3, 4, 5. So 2, and then 1, 2, 4, 5. So if you rotate this guy half the page, and what's half the page? Let's see if it's 100. This is 180-degree rotation. Gives you half the page. So we go around here, and that's represented by -x, -y. So when we took those and put us here, now how do we get over there? So we're going to go over 1, 2, 3. Let's just check it. Over 1, 2, 3. Check this one. 1, 2, 3. So it's a translation followed by a translation along vector. So we saw that it was 3 to the right and it didn't go up and down. So it's 3, 0. And this is represented by x plus 3y. And that shows, therefore, ABC is congruent to DEF, because once we move it over it maps onto it. If one of these had not been 3, say if this had been 4, then that would mean this triangle is bigger than this, so it's not a translation. All right, so over here it's just a line segment. So you're going from here to here to there, from there to there. Let me help you just a little. Take a pencil. Say that the eraser is X and that the sharp end is Y. P and Q up here, so X and P and Q and Y. So your pencil's facing this way. Up here it's facing that way. So think about what we would have to do to go from here to here. Oh, there's your hint. So that'll get you up here, and then you should be able to scoot over and get the rest. All right. Summaries at the bottom. I'm going to let you guys work that out. How is a figure affected by reflections in 2 lines? That's at the top of the first page. What does a translation vector of a glide reflection tell you? That's also at the top of the first page. Until next time, have a good night.